So in this video, I'd like you to calculate this integral, definite integral from -2 to 0 of 2 to the power of x integrated with respect to x. Have a go at it with pen and paper and then come back and a detailed solution and some comments will follow. So if you stop now, you can come back when you've had a look at it. Okay, welcome back. So on this slide, we want to calculate this integral. And we see that we have something to a power of x. And the key observation that we need to make is if this wasn't 2, but it was e, the base of the natural logarithm, we wouldn't have a problem at all because we know how to integrate and differentiate e to the x. So what we need to do is to rewrite this as e to the x in some way. So I'm going to talk about it here in two different ways. So the first thing you could do is you could say, well, 2 can always be written as e to a power. So let's just show that 2 is a positive quantity. And if I sketch here the graph of y is e to the t against t, then you can see that all positive numbers are possible outputs for e to the t. So if you want to get 2, then 2 is higher than 1, so it's going to be a positive power of e. That power is going to be less than 1 because e to the 1 is e, which is 2.71828, etc. So it's somewhere between 0 and 1. You could work it out numerically. And that's going to be the power, so we can do it. So now, let's find that power. The way to find powers is take logarithms. Take logs of both sides. Natural log of 2 is the natural log of e to the a, and that's just a. So a is log 2. So 2 to the x is e to the log of 2, because we've just shown that's what that is, all raised to the x. And then from the rules for powers, we just multiply these two powers together, and I'm going to put the x in front to make it clear it's not inside the logarithm, it's multiplying the log. So we've been able in this way to write 2 to the x as e to a power of x times a constant. So that's one way of doing it. The other way, which is the way that I would probably use myself, is I would say, well, if I've got 2 to the x, 2 to the x is always going to be positive. So I can take the natural log of it. I get the natural log of 2 to the x. And if I take the exponential of that, it will take me back because the log and the exponential are inverse functions of each other. So I can always write 2 to the x in this convoluted way as the exponential of the log of 2 to the x. And then I can use the rules for logs to bring the x down in front, and I have e to the x times log 2. And that's exactly the same result as there. Okay, so let's go back to our integral, rewrite our integrand in this way. So our integral is the integral from -2 to 0 of e to the x log 2 with respect to x. And the integral of an exponential is going to be an exponential. We don't change the argument of the exponential at all. And now we want to have some number here, perhaps, such that when we differentiate this, we obtain the integrand. Now, if we differentiate the exponential, we get the exponential with the same argument. Good. And then by the chain rule, we multiply by the derivative of the argument, and the derivative of x log 2 with respect to x is log 2. So we would have an extra factor of log 2 in front there. We don't see it, we don't want it, so that tells us just to put here a factor of 1 over log 2 there. Notice, by the way, 2 is positive, log of 2 is real. So now, we could start evaluating this immediately, but before we do that, it's very sensible, I think, to rewrite this. Remember, here we've just got e to the x log 2. We wrote it in this way, so that we could integrate it. And now we can just say, well, e to the x log 2 is 2 to the x. So I'll just write this again, but rewrite this as 2 to the x. And now on the next line, we'll evaluate this at the limits. So we have a 1 over log 2 multiplying everything. I'll just pull it outside, open a big bracket. From the upper limit, we have 2 to the naught. X is naught. 2 to the naught, that's just going to be a 1. Minus, and then this evaluated at the lower limit. Remember, we pulled the 1 over log 2 out in front. So we have a minus sign, and then it's 2 evaluated at minus 2. 2 to the minus 2 means 1 over 2 squared, so it's a quarter. So this is 1 minus a quarter. So overall, this is 3/4. So our answer for the integral is 3/4 times 1 over log 2. The logarithm of 2 is positive. 2 is greater than 1, so its log is positive. This is a positive number, and we expect this integral to be positive because we're integrating from left to right, and our integrand is positive. So the sign is positive as expected. And that is something that we ought to welcome. So, what we've done on this slide was we said to integrate anything like this, what we want to do is to recast it in the form of e to the x, perhaps times a constant. And I explained 2 different ways of doing that. This is the way I would normally use myself. I would just say anything to the x is e to the log of the anything. And then we've used the rules for logs to bring the x in front, and this is now in a form that is easy to integrate or differentiate. And then we just use the rules, and the only thing that I think is worth pointing out is before we evaluated things, we just tidied this up again immediately using our result. Okay, with that, I'm going to give you an exercise to try and do on the next slide. So the exercise that I'd like you to try to calculate now is the integral from 0 to 2, 1 over 2 to the x, all integrated with respect to x. And I will give you a hint and the answer in a moment, but you could try it first with pen and paper and then come back to the hint. Okay, welcome back. Let me give you the hint. So the exercise on this final slide is here to integrate from 0 to 2, 1 over 2 to the x with respect to x. And the key thing to notice is what the powers here mean. 1 over 2 to the x is the same as a half to the x, and that can also be written then as 2 to the minus x, because a half is 2 to the minus 1. You could do that in various ways, but it's 2 to the minus x is the easiest way to write it. You then use exactly the same method as before. You're careful with minus signs, and you will again get 3/4 times 1 over log 2. Why do we get the same result? Well, let's think about the graphs. In the previous exercise, we were integrating y is 2 to the x from minus 2 to 0, and that corresponds to this area here, because the integrand is positive. In this exercise, we are integrating 2 to the minus x from x is 0 to x is 2. That curve looks like this. It is a mirror image of this curve about the y-axis. And this area, again above the x-axis, is identical to this area, so you should expect to get exactly the same value for the integral. With that, I'll stop this video.